Hello, today we are doing lesson 1.6a, which is representing functions as rules and tables. We're going to start off with a little bit of vocabulary to introduce us to functions. So first, the first vocab word is function, which means for each input, there's only one output. I like to think of a pop machine. If I push this one button on the pop machine, I should get one Coca-Cola out of here. If I push this one that says Sprite, I should get a Sprite out of here. So for every input, I only get one thing out. I can't push the Sprite button and sometimes get a Coke and sometimes get a Sprite. It doesn't work like that. Hopefully, right? If the pop machine is working correctly. But that is what a function is. For every input, there is one output. So a couple other vocab words. Another word for an input is our domain. Domain is what we put into our table or our function. A lot of the times we have an XY table. We put numbers into an equation or to a function for X, and we get out Y. So these two both have the word in because they are what we put in to our equation, the X values. Then whatever we get out is our Y values. So our output is what we get out of our equation. Another way to remember this, our letter G, I like to say, has a Y hidden right in it. It's our Y values. We put in for X and we get out Y. For example, if I had an equation Y equals X plus 2, if I put numbers in here, then I can figure out what is Y. Our independent variable, these two are very similar to these two up here, just different words or terms to describe them. These are more science terms. Independent variable is our X values, again, what we put in to the equation. It's independent. It stands by itself. Our dependent variable is then Y. We don't know what Y is over here until we know what we're putting in for X. So our Y is dependent on our X value. So let's take this and look at a couple problems. A little bit more about functions. It says a relation is a set of ordered pairs that relates our input and our output. So these are listed first here as ordered pairs, X and then Y. We can do the same thing using a table. This is just an XY table or an input-output table. For example, we have some sort of equation that's giving us, if we plug in a 2, it will give us a 5 out. So this is a function because for each input, 2, 4, -1, and 0, each of these, we get out one number. Okay? If I were to add some more terms or more inputs to this, let's say I put in a 3 and I get out a 5. There aren't any other 3's on here, so that could work. However, if I put in a 2 and I get out an 8, well, that's not going to work because if I push a 2 here and get out 5 and push a 2 and get out 8, that's like your pop machine or your Redbox, your DVD player. If you push one button, you shouldn't get two options. If you push one button, you should get your one option out. Okay? So this one would not make it a function. This one would continue to make it a function there because there aren't any other 3's. So it says a relation is a function if for each input there is exactly one output. So let's take a look at a couple examples. Tell whether the relation is a function. Explain your answer. So if we looked at each of these, if I push the button 4, I get out a 3. If I push 6, I get out 8. If I push 3, I get out -2. Now, if you think, on a pop machine, you can have two buttons that say Coca-Cola. So you could have two buttons, let's say 5 and 6, that gives you the same answer of 2. That is okay, but you can't have the button 5 give you two different options out of it. Do you see the difference? So if we look at our example here, I'm only looking at the input. For every input, there is one output. So we have 4, 6, 3, 0, 1, -7, and -2. Each of those are different numbers, and we got different answers for our outputs. It is okay that we got, for example, the same number here out. That is okay. Because I could have this button on my pop machine and this one be Coca-Cola because maybe that's a popular choice. Okay? So this is a function because all of our inputs are different. Each input has one output. So let's look at the next one. For our inputs, 3, 4, -2, and 3, well, we have the same input here 2 times. If I push the button 3 and get out an 8 and a 7, well, that's not going to work. So this is not a function. And it says explain your thinking. Well, because the 3, oops, that doesn't look like a 3. Let's try it again. Woo! Come on. Because 3 has more than one output. And we can't have that. For every input, there's only one output, and this input has 2 outputs, so it's not a function. Let's look at the next couple. It says make a table for the function using -2, -1, 0, 1, 2 as your domain. Remember, domain is what we are going to plug in to our function, and then identify the range. So I like to make an XY table or an input-output table. And they're telling us what we're going to put in for X are these numbers right here. Those are our domain, what we're plugging in. We're going to plug in a -2, a -1, a 0, a 1, and a 2. So if we plug those in for X here, we should be able to get out or figure out what is Y. So right now we have -2. I'm just taking our equation here, y equals x squared minus 1, and plugging in these numbers for x. So we have -2 squared minus 1. We need to figure out what is y then. Well, -2 times -2 is 4, and 4 minus 1 is 3. So we put in a -2 and we got out 3. Then, if I plug in a -1, we have -1 squared minus 1. All I'm doing is looking at this part of my equation, plugging in for x. -1 times -1 is a positive 1, and 1 minus 1 is 0. Then if I plug in a 0, we have 0 squared minus 1. Well, 0 times 0 is 0. 0 minus 1 is -1. Then if I plug in a 1, 1 squared, 1 times 1 is 1. 1 minus 1 is, again, 0. And then last, if I plug in a 2, 2 squared, 2 times 2 is 4. 4 minus 1 is 3. And you can kind of see the pattern that we created here. So this is our XY table. It's telling us that this is a function because for every input there's one output. It's okay that 2 of the outputs are the same, just not the inputs. So it says make a table, use those as your domain, and then now identify the range. Our range was not our x values because that was our input or our domain. Our range is our y values, what we get out. Remember the hidden y in here? The range is our y values. So we got out a 3, a 0, a -1, 0, and a 3. Now you don't need to list these two twice because they were listed over here as well. So if you want to just list those 3 numbers, you may. Let's try the same thing with the next one. Here's our function or equation. We're going to make an XY table. and they want us to plug in the same numbers, -2, -1, 0, 1, and 2, to figure out what is y. So we're going to take our equation, and every time we see x, we're going to plug in whatever x is. So first, we have -3 times x, which is a -2, plus 2. So a negative times a negative makes a positive 6. 6 plus 2 is 8. Then if I continue plugging in the next number, we have -3 times x, and x is -1, plus 2. Well, a -3 times -1 is going to give us 3. 3 plus 2 is 5. Then if I plug in a 0, -3 times 0 is just 0, so 0 plus 2 is 2. -3 times 1 is just -3. -3 plus 2, there's more negatives, it's a -1. Then -3 times 2, that gives us -6, and -6 plus 2, there's more negatives still, it gives us a -4. So here in our table, we have our inputs and our outputs, also known as our domain and range. So down here at the bottom, I'm going to list our range, what we got out. We got out 8, 5, 2, -1, and -4. So on our next slide here, we're going to actually be writing a rule, or trying to figure out our pattern, how we actually get this equation from the table. And if you notice, a couple of things in common here. Our equation up here says -3x plus 2. If we just look at this -3, if we look at our pattern here, we really have from one number to the next, if I'm going from one to the next, what's happening? How do I get from one number to the next? 8, 5, 2. Aren't I going down by 3? So our pattern from one number to the next is really our function rule. What's happening? We're going down 3, and this 2 is really going to be where we start at 0. If I were to plug in a 0, where are we beginning that graph if we actually were to graph this, which we'll get to later on in this chapter. So, if that doesn't make sense, we'll take a look here. It says write a function rule that relates x and y. So, we need our function rule. How are we getting from one number to the next? As long as our inputs are going by ones, which they are 2, 3, 4, 5. So how do I get from one number to the next? What's my pattern? From 3 to 4.5, I'm going up by 1.5. I'm going up 1.5. So my pattern, we're going up 1.5. And if I look at my equation, what we're really looking for is that multiplied by x. So let's just try it out. If my equation would say y equals 1.5x, if I plug in a 2, let's see if we get out a 3. So if I plug in a 2 here, 1.5 times 2 will give us 3. So that works. If you're not sure, try another one. 1.5 if I plug in a 3. Well, 1 times 3 is 3. 3 times a half would be 1.5, so 3 plus 1.5 would give me 4.5, or just use a calculator. 1.5 times 3 is 4.5. So this is working. This pattern is working. All we're really doing, you guys, is, we'll get to this later on, we're thinking, what is our pattern or a function that goes here, or our pattern, and if it doesn't work, what do we need to add or subtract to our equation so that it does work every single time? So let's take a look at this next one. Hopefully this one will help us figure out this rule, this function rule.